Next, Saurabh Das Pattanayak. Just a few minutes back, what we have heard, he is very busy with his father who is admitted in the hospital. So might be he will not be able to attend. And last but not the least, Ankita Dotto. Ankita, চলে এসো. So now microphone is handed over to the chairman. Chairman sir, please start. You are also carrying pen drive. Transfer.
Okay. দিয়েছো এটা? পড়লে এইটা দিন। Good morning. In this session, we'll be discussing liquid waste management issues and challenges. You all know that our water bodies, especially rivers, are getting polluted due to discharge of untreated or partially treated sewage. Also, untreated, partially treated effluent coming from different industries are also getting mixed with the river or other water bodies. Surface runoff carrying pesticides, insecticides, etc. are also getting discharged or getting mixed with the river as well as other water bodies. Dumping of solid waste is also causing concern for us with respect to water bodies. Even dead bodies, dead animals are also getting dumped in the water bodies. Cattle shed waste, instead of converting the animal excreta or cattle excreta into biogas, these are getting also mixed with the river. It is our utmost duty to keep environment clean. As a result, all water bodies, including rivers, should be kept clean. In this context, you know about various action plans taken with respect to river Ganga. Ganga cleaning work started in the year 1985 with Ganga Action Plan Phase 1 as well as Phase 2. Currently, Government of India has taken up flagship program under Namami Gange program. It is more than 20,000 crore rupees investment, by which it is not only abatement of pollution of river Ganga, but also very many other action plans with respect to Ganga river basin have been taken up. Under this context, district river management plan, urban or city management plans are also being taken up so that we can keep river Ganga clean. Under this particular scheme, a lot of sewage treatment plants have been installed. Apart from that, we have Amrut program, by which we are also installing wastewater treatment plants. When you look into the rural India, there also the liquid waste management are given importance by the Government of India as well as state government. Under Swachh Bharat Mission 1, Swachh Bharat Mission 2 program, we are giving emphasis on the liquid waste management. Actually, Swachh Bharat Mission 1 program was intended to provide toilet to the communities, rural communities. It was a successful program by the Government of India as well as state government, by which we have become ODF, open defecation free. Under Swachh Bharat Mission 2 program, we are heading with ODA plus, that is solid waste management, liquid waste management. Also, we are stepping forward with ODA plus plus, with fecal sludge and septage management system. Now, if we look into the liquid waste management system, we find that around 40% treatment facilities are available for the cities and town in the country. 60% wastewater are not getting treated and it is getting discharged in the water bodies, including river. But out of that 40% treatment facilities that we have, actually treatment capacity, treatment that being taking place could be around 70%. That means having facilities of treatment, yet we can achieve the target or the capacity of the waste treatment plant. There are very many reasons. One of the reasons is that we are not laying total sewerage system for the city. Maybe we have sewerage system for mega metro cities or some cities with World Bank funding. Under Namami Gange program, we have installed sewerage system, but the funds are limited. As a result, we have taken the concept of interception, diversion, and treatment of wastewater. As a result, in a sewage treatment plant, we find the treatment capacity is much less. Even some treatment plants are having treatment of only 50%, 60% like that. So, our objective would be to collect more wastewater, convey it to the sewage treatment plant. The treatment plant should run according to the intended quality. The quality that we have to follow is not MOEF standard. Ministry of Environment, Forest, Climate Change standard is there, but Honorable National Green Tribunal on 2019 recommended that the treated wastewater standard should be modified, and this has been followed by most of the civic bodies, including development authorities. In this context, I like to mention that in West Bengal, that is in Kolkata metropolitan area, we have experience of working with waste stabilization pond, a natural treatment system. Nature-based treatment system we find is excellent in upgrading the quality of the wastewater. We are not against with the high technology or SBR or MBBR or extended aeration system of activated such plants, etc. But my point is this, that even natural-based treatment system is giving us very good results. There are 9 waste stabilization ponds are working in Kolkata metropolitan area. With this introduction, I request Ankita Datta, who is a research scholar, PhD research scholar in School of Water Resources Engineering, Jadavpur University, will be presenting her study relating to waste stabilization pond. Ankita. ये ভাস্কর একটু পিছিয়ে না, তো গার্ড পড়ে যাচ্ছে, স্ক্রিনটা একটু পিছিয়ে পিছিয়ে আমরা এখানে চলে আসছো, এখানে পিছিয়ে না, অত পিছিয়ে না, পিছিয়ে না, ওটা গার্ড হয়ে যাচ্ছে।
Good morning, honorable dignitaries on the dais and off the dais. Myself, Ankita Datta. I am pursuing PhD from School of Water Resource Engineering Department, Jadavpur University. At first, I am very much thankful. I am very much thankful to the IPHE for organizing the program and providing me to this opportunity to present here and present my PPT. Today I am here to present my work. The work has been carried out under the guidance of Professor Unnao Mujumdar sir, Professor Ashish Mujumdar sir, and Assistant Professor Dr. Gaurav Banerjee sir. Today my topic is performance evaluation of nature-based sewage treatment system, waste stabilization ponds. A case study. Background. India has witnessed a rapid increase in urban population during the last few decades. If you see in India, 72,368 MLD wastewater is generated in the urban areas and 39,648 MLD wastewater is generated in the rural region. So, all cities and towns are augmenting water supplies to meet the increasing water demand. But lack of adequate wastewater the treatment facilities is resulting in untreated sewage. So untreated sewage is disposal into lake, river and other surface water bodies without any kind of treatment. So treatment is very much required for abatement of pollution of river Ganga. Installation of sewage treatment plants are a necessity apart from other relevant measures. Accordingly, the Kanaipur sewage treatment plant was constructed under Ganga Action Plan Phase 2, having a capacity of 22 MLD to treat sewage generating from Konnagar and Uttarpara Kotrang towns in Hooghly district. Waste stabilization pond were constructed as a STP. The waste stabilization pond system considered as an environmentally sustainable and energy efficient technology suitable for Indian climatic condition. So next, in the study area, my study area is Hooghly district. In Hooghly district, 4 subdivision is present: Arambagh subdivision, Srirampur, Chandanagar subdivision and Chuchura. So in Kanaipur waste treatment plant is situated in the Srirampur subdivision area, Srirampur Uttarpara block. If you see the introduction, waste stabilization ponds are large but shallow lined basins are designed for the treatment of domestic sewage. In the waste stabilization system consists of anaerobic, facultative and maturation ponds where organic matters, nutrients, pathogens are removed through ecologically balanced wastewater treatment system using sunlight, bacteria and algae. If you see the first stage in the anaerobic pond allows settlement of suspended solids. In second stage, bioremediation takes place in the facultative pond under symbiotic relationship of algae and bacteria. In the third stage, bacterial die-off takes place in the maturation ponds. Waste stabilization pond provide long hydraulic retention times, allowing organic matter, nutrients, pathogens to be effectively removed. The treatment process mainly relies on a symbiotic relationship algae and bacteria, where algae supply oxygen through photosynthesis and bacteria degrade organic matters under aerobic conditions. If you see the schematic and realistic aerial layout, in this slide, I have to mention that in this area, too much greenery and the pond and the sides are too much covered with the greenery. So in this area, temperature is always less than 4 to 5 degrees centigrade than the city temperature. And we say that in this area is always called the carbon sink. So carbon is absorbed by the trees, plants, algae, sediment, soil. So automatically carbon is reduced in this area and through the photosynthesis. And carbon sequestration also be occur in this area. Here, in this treatment, waste treatment, one stream chamber is present, 2 grid chamber is present, 2 anaerobic pond is present, 2 facultative pond is present, which is all a parallel formation, and after that the maturation ponds, 2 maturation ponds is present, which is the series connection. After the anaerobic, after the maturation pond, the wastewater is going to the canal, channel, chlorination chamber, and after that it will used as a agricultural purpose. The treated water is used as an agricultural purpose. If we see the original picture of this area, this is the anaerobic pond. This is an anaerobic pond which is a depth is almost 2.5 to 5 meter. The function of this anaerobic pond is settling of suspended solids and anaerobic digestion and bioremediation takes place. Detention time is 1 hour, 24 hours, 1 day. BOD removal is 40 to 70%, temperature dependent. So here the anaerobic pond BOD is removed by the dependent on the temperature. So if our temperature is 10%, the BOD is removed only 40%. If temperature is high, then temperature is 20%, this BOD is removed 60%. And if the temperature is 25 degrees centigrade, the removal of BOD is 70%. So greater than 25 degrees centigrade, BOD is always removed with 70%. So it is a temperature dependent. BOD is removed under the temperature dependent. So pH in this anaerobic pond is to maintain around 7.5 to avoid odor problem. Anaerobic pond generally does not contain dissolved oxygen. Algae is not grown in the anaerobic pond. The space for sludge is removal interval is 1 in 2 or 3 years. BOD loading rate is 100 to 350 gram per cubic meter day in Indian climatic condition. Next, the wastewater is coming in the facultative pond after anaerobic pond. In this facultative pond, depth is facultative pond is 1 meter to 1.5 meter. Function of facultative pond is BOD removal takes place under aerobic condition where algae and bacteria maintain symbiotic relationship. During daytime, BO concentration increases due to algal photosynthesis in the facultative pond and normally reaches to supersaturation condition. BOD loading rate in facultative pond in India 150 to 325 kg per hectare day. BOD loading rate varies with respect to latitude of the place of construction. BOD removal of facultative pond is 70 to 80%. I will discuss briefly in my next slide. After the facultative pond wastewater is coming in the maturation pond, here bacterial die-off takes place in maturation pond. Fecal coliform remove takes place following first order kinetics. So, higher number of maturation pond in series are capable of removing higher quantum of fecal coliform. Depth of maturation pond 1 meter to 1.5 meter. Temperature plays an important role in removal of bacteria. This is the algae bacteria symbiotic relationship in a facultative pond. This is a very important mechanism in the facultative pond. If we see the wastewater coming from the anaerobic pond, the settleable solid is accumulated at the bottom, and there organic matter bacteria degrade the organic matter and release the CO2, carbon dioxide, ammonia, methane and H2S gas. So in this gas moves the upward reaction. In this zone is called anaerobic zone. In the upper layer is the aerobic zone where photosynthesis takes place during the sunlight. And algae is present here. So, when the bacteria is degrade the organic matter, then COD is released. This COD is taken by the algae, and algae produces the oxygen by using sunlight during the photosynthesis. So, algae produces the oxygen, and oxygen bacteria takes the oxygen, and bacteria release the carbon dioxide, and algae takes the carbon dioxide. So this is a symbiotic relationship takes place in this facultative pond. So variation of design load in facultative pond. If you see latitude, BOD loading rate is always depend on the latitude. So higher latitude gives the lower BOD loading rate, and lower latitude gives the higher BOD loading rate. So that means the lower latitude gives the higher solar radiation and higher temperature is here, and the higher latitude gives the lower solar radiation and lower temperature. So southern portion of the India is always warmer than the northern portion. So if you see the 36° north is our 36° north to 8° latitude. So if you see the 36°, this is the Jammu Kashmir and Ladakh, and 8° is the Kanyakumari, and 32° is all 32°, that means Chandigarh, and 28° is Delhi, Uttar Pradesh, 24° Madhya Pradesh, Chhattisgarh, 20° Nagpur, Maharashtra, and 16° Hyderabad, 12° Bangalore. So we can see that different places BOD loading rate is different. So design will be always different, depend on the latitude. Our study area is Tanai sewage treatment plant. Here latitude is 22.72 degrees. So our BOD loading is 233 kg per hectare day. So we can assume the BOD loading from this equation 375 minus 6.25 L means latitude. These are diurnal variation of BO profile in facultative pond. We have studied the diurnal variation of BO profile from 6:30 AM to 4:30 AM. 4:30 PM. So if you see the graph, DO is very much less at 6:30 AM, which is 0.63 milligram per liter. And when the time increases, after the sun rises, 8:30 PM, DO is also increases 6.30 milligram per liter. At 9:30 AM, DO is also increases 8.74 milligram per liter. And 10:30 AM, DO is 11 milligram per liter. At 11:30 AM, DO is reaches the 12 milligram per liter. And 12:30 AM, DO is touches 14 milligram per liter. 2:30 PM, the DO is reaches 16 milligram per liter. So and the 4:30 PM, DO is highest than 19.1 milligram per liter. So DO is increasing. DO is increasing, and when the time was 6:30 AM, the saturation was 8.2%. And when the time was 4:30 PM, the saturation was 266%. That means super saturation. If we see, DO is always decreasing when the increasing the depth. If you see the graph, the DO is inversely proportional to depth. So depth is increasing, DO is decreasing. If you see the, we have studied our 4 depth, 0.5 feet, 1 feet, 2 feet, and 3 feet. So DO is decreasing. Variation of dissolved oxygen with time. We have studied also with increasing the time, the DO is also increases at the depth. If you see the 0.5 feet depth is at 6:30 AM, DO was 0.63 milligram per liter. 7:30 AM, DO was 2.3 milligram per liter. 8:30 AM, DO was 6.2 milligram per liter. 9:30 AM, DO was 8.2 milligram per liter. 10:30 AM, DO was 12 milligram per liter. And 12:30 AM, DO was almost 14 milligram per liter. And 2:30 AM, 2:30 AM, DO was 16 milligram per liter, and 4:30 PM, DO was 19.1 milligram per liter. If you see the same 1 feet depth, at 4:30 PM, the DO was 12 milligram per liter, and the 2 feet depth, DO was 8 milligram per liter. So depth increasing, the DO is also increasing with the depth, and with respect to time, DO is also increasing with respect to time. Same is happening the duration variation DO profile in faculty pond 2. In this pond, DO is almost reaches 20.13 milligram per liter at 5 p.m. and starting from 7 p.m. when the DO was 1.01 milligram per liter. Variation of dissolved oxygen with time, facultative 0.2. DO versus time, 0.5 feet depth, 1 feet depth, 2 feet depth and 3 feet depth. Time increases, DO is also increases at the same manner. After that, after the maturation pond treatment, the tertiary treatment also occurred in this study. In Bain scale laboratory model, treatability study for the tertiary treatment was carried out. Along with optimum dosage was applied with rapid mixing followed by slow mixing and filtration. The laboratory analysis results indicated upgradation of treated wastewater quality conforming to Honorable National Green Tribunal recommendation. After maturation pond, the results becomes not less than BOD not less than 10 milligram per liter, TSS not less than 20 milligram per liter, COD not less than 50 milligram per liter. So after the tertiary treatment, it comes down and as per guidelines, it will come the guideline. And along with optimum dosage was applied when rapid mixing for 1 minute and slow mixing for 8 minutes and then settlement for 1 hour. This is the process of tertiary treatment in a laboratory scale. Performance monitoring of waste stabilization ponds. pH in a raw inlet 7.08, anaerobic pond outlet 7.22, facultative pond outlet 7.25, maturation pond outlet 7.53, and the tertiary treatment 7.25. And the TSS is the 84 plus minus 8.5, the value of raw inlet, anaerobic pond outlet 35 plus minus 0.6, the anaerobic pond outlet. So it comes down and the facultative pond 26 plus minus 0.5 and the maturation pond 21 plus minus 0.7. In the tertiary treatment, it comes 16.5 milligram per liter. The COD was raw inlet is 120 plus minus 40. It comes in the anaerobic pond outlet is 54 plus minus 0. And facultative pond outlet 33 plus minus 0.7. In the maturation pond, it comes 27 plus minus 0.2 milligram per liter. After the tertiary treatment is 20.80 milligram per liter. In the BOD, in the raw inlet was 62.5 plus minus 6.5. Anaerobic pond outlet 26 plus minus 0.5. In facultative pond, it comes 80 plus minus 1.5. And maturation pond outlet 15 plus minus 0.2. And the tertiary treatment, it comes 8.73 milligram per liter. Total nitrogen 17.5. Anaerobic pond outlet 12.35 milligram per liter. Facultative pond outlet 9.21 plus minus 0.5 milligram per liter. And the maturation pond outlet 8.83 plus minus 0.8 milligram per liter. And the tertiary treatment, it comes 5.030 milligram per liter. Total phosphorus 2.44 plus minus 0.2, 2.36 in the anaerobic pond outlet plus minus 0.5, 2.11 plus minus 0.25 in the facultative pond outlet, and the 1.15 plus minus 0.15 in the maturation pond outlet. In the tertiary treatment, it comes 0.87 milligram per liter. Total volume from MPN per 100 ml, which is 76,101, it comes 37,610 MPN per 100 ml. This is a bar diagram of performance evaluation of waste stabilization pond. Result and discussion. The influent wastewater had a pH of 6.94, which increased slightly with the pond system and remained with the neutral range throughout the treatment. Total suspended solids TSS decreased from 88 milligram per liter to 16.5 milligram per liter, achieving an overall removal efficiency of 81.3%. Biological chemical oxygen demand BOD and COD decreased from 76 milligram per liter to 8.73 milligram per liter and 140 milligram per liter to 20.80 milligram per liter, resulting in an overall renewable efficiency 88.5% and 85.1% 0.14% respectively. Total nitrogen and total phosphorus concentration decreased from 16 milligram per liter to 5.30 milligram per liter, and it comes to 2.22 milligram per liter to 0.87 milligram per liter, achieving 64.5% and 64.34% renewable respectively. The highest renewable efficiency was observed fecal collie from 96.9%, followed by total collie from 92.9% in the waste stabilization pond. Dissolved oxygen exhibited a strong diurnal variation, increasing from 0.62 milligram per liter at 6:30 a.m. to 19.10 milligram per liter at 4:30 p.m. at 0.5 feet depth in pond 1 and 1.01 milligram per liter at 7 a.m. to 20.59 milligram per liter at 4 p.m. in pond 2, indicating intensive daytime photosynthetic activity. Surface waters remain highly oxygenated throughout the day, with afternoon DO concentration exceeding 15 milligram per liter in both ponds, where the deeper layers maintain comparatively lower DO levels, demonstrating clear vertical stratification. In the conclusion, to achieve sustainable environmental management, green technology needs to be applied as much as feasible. Priority must be given for conservation of natural resources, development of green technology. Many indigenous traditional technology may be upgraded as green technology for societal benefit. Ecological balanced approach may be adopted to develop green technology. Green technology should aim at leading the right way. And last slide, thank you very much.
Thank you. So thank you very much for your presentation. This paper is now open for discussion. If you have any questions, yes, please.
I have a very simple question. We have found after tertiary treatment, the biological bond,
After maturation.
I think 8.7. Is it an average figure throughout the year, or have you, what is the status in the long rainy day, that is long sunny days, and symbiotic relation is that?
In the sun, if you see the sunny day, is the average. This is the average figure of 8.73 after the maturation bond treatment is the tertiary treatment. If you see the sunny area or sunny day, the always sunlight intensity is less, so the photosynthesis is become less. So as usual, BOD value is BOD level is too much less than the summer season. A symbiotic relationship takes less than the summer season occurs.
So, very simple that during the non-sunny days, rainy period, and the symbiotic relation will affect to some extent.
Some extent.
What is the purely renewable on the tertiary treatment? Have you observed it?
In the sunny area.
In the tertiary, after tertiary.
After tertiary treatment in the sunny day,
Is it 8.73 or?
it's higher the value. It's we become 10 milligram per liter, 9 milligram per liter. We have seen the after the tertiary treatment in the sunny season.
No, it is not studied. It is a laboratory feasibility
Laboratory-based.
study carried out with respect to tertiary treatment. Actually speaking, KMDA like to introduce tertiary treatment so as to conform to the National Green Tribunal. So they requested the School of Water Resources Engineering, Jadavpur University, to see the performance efficiency of the existing vegetation pond at Kanaipur, that is for the Konnagar and Uttarpara town, but how to upgrade. So accordingly, extensive study has been taken with respect to tertiary by adding chemical as well as filtration. But it is not reflecting your answer whether during the rainy days this has been introduced or not. Certainly not. But my point is this, that it is a very good question that you have raised. Sunny days means no ski time. Normally we consider 70% days of the year sky is clear. So Indian waste stabilization pond design is based on 70% sky clearance factor. We consider this. But in Europe, if you go, you will find that 6 months there is no sunlight. So in Europe, waste stabilization pond cannot function. So India is a place where waste stabilization will function. But your point is well taken. If we have a 3 continuous, sky overcast with cloud, then the efficiency of the treatment plant will fall, no doubt. Issue is that the oxygen level at 5 o'clock during the dawn, sun setting, it is becoming supersaturation condition. If you see the normal temperature, say for example, if it is 20 degrees centigrade, the saturation value of oxygen in water is 9.2 milligram per liter. Now we get around 5 o'clock, 5:30, 18, even 20 milligram per liter oxygen content in the pond. That is supersaturation condition due to photosynthesis. During the night time, when there is no photosynthesis, the bacteria is utilizing the oxygen. But our intention is DO zero will not take place in facultative pond. At least 1 milligram or 1.5 milligram DO must be present in the facultative pond. So the study indicated, their study, around 0.8, 0.1, 0.9, 1 milligram, 1.1 milligram oxygen is present at 5 o'clock in the morning during the sunrise. Now the question comes, what you have mentioned, in the morning the sky is full of cloud, no sunlight. Then the situation will change. You will not get the supersaturation condition at 5 o'clock in the evening. Then the pond will not function, maintaining the symbiotic relationship. But this will happen maybe once or twice a year. That much I can say. So your question is well taken. It is to be considered. So I think she will work with respect to this. What you have suggested. The rainy days are coming, so we will ask her to take sample and do the needful. Thank you very much.
Those days analysis also need to be incorporated.
Right. Right.
Another question that generally told, obviously, stabilization point for use, obviously, good technology, no doubt, but so far as the land requirement is concerned.
Roughly, our estimation is that 0.6 to 1 square meter per person land is required. Fortunately, in West Bengal, I don't know whether I say term used fortunately, our raw water BOD is varying between 60 milligram per liter to 100 maximum. Many sewage treatment plants are running with 70, 65 milligram per liter BOD because we people are using huge amount of water compared to any other part of the country. Yes, that is the reason we find the BOD input is less. So, that is the... Yes. Any other question? Yes, sir.
My name is Musa. I do not understand the figures that you have projected there. Not being a research guide, neither an examiner. What I am interested to know is that does the treated water comply with the standards? And there again I am confused about what is the standard, is the NGT standard or there is a national standard? Why NGT had to come in? Why had NGT had to interfere if our standards fail? Then what is the compliance of the treated water throughout the year? That is my question. That has to what standard?
Yes, answer.
Sir, as per Green Tribunal, Honorable Green Tribunal guidelines, BOD comes down the less than 10 milligram per liter, COD less than 50 milligram per liter, TSS less than 20 milligram per liter, and TA total nitrogen less than 10 milligram per liter and total phosphorus less than 1 milligram per liter. So after the treatment of maturation pond, we have to see that the value of the BOD is around 16 milligram per liter, COD is 55 milligram per liter. So it is not come down the less than 10 milligram per liter, less than 50 milligram per liter. That's why the tertiary treatment has done after the maturation pond outlet treatment of water. And it is used in a
Okay. His real answer is, your question's real answer is, it is conforming to MOEFCC standard. Ministry of Environment, Forest and Climate Change standard, this treatment plant is followed. If disinfection is done, if, I say, it is not conforming to Honorable National Green Tribunal. According to National Green Tribunal, total suspended solids should not be more than 20 milligram per liter. BOD should not be more than 10 milligram per liter. COD should not be more than 50 milligram per liter. Total nitrogen should not be more than 10 milligram per liter. Total phosphorus should not be more than 1 milligram per liter. And the fecal coliform preferably must be less than 100 per 100 milliliter. Permissible limit for that has been said to be not more than 230 per 100 milliliter. So therefore, this treatment plant is not conforming to Honorable National Green Tribunal. That is the two answers that you raised.
So, but why and how? Is the entity different? How did they have to intervene in it?
Issue is that this treatment plant was constructed under Ganga Action Plan Phase 2. Phase 2 means late 90s. At that time, Honorable National Green Tribunal was not there. Honorable National Green Tribunal came into picture in 2019 onwards. So therefore, this treatment plant was designed on the basis of MOEF standard and it is conforming to that, provided disinfection is done. This is very important thing. Disinfection, chlorination was not done earlier. Now it is becoming mandatory and Namami Gange has recommended disinfection to all operators or municipalities or KMD, etc., to do disinfection. So therefore, if we do disinfection, then bacterial quality can be maintained. Okay. But uniqueness of this particular treatment plant is that if you go to the treatment plant, no electricity bill is required. Number two, temperature of the area is 4 degrees centigrade below the city area. The air quality is much better compared to the city. PM 2.5, PM 10 is very less and much less compared to city. And you will feel a beautiful natural environment. It is a carbon sink. That is also important. So therefore, if land is available, this is a unique treatment system that we can say. Okay. Thank you, sir. Yes, sir.
I am Deepak Kumar Shankar. My question is, this project, how much influent it can handle at it?
How much?
How much quantity of influent it can handle?
22 ml.
22?
2 mld.
22 MLD is the capacity, million liter.
And does this study check the yearly verification of this tertiary output?
Yearly verification is not till now not done the tertiary treatment. This is a laboratory based treatment we have just started.
Thank you very much.
Thank you. Okay. Thank you very much for your presentation. Thank you very much. I now take up the next speaker. You all know that ozone can be used for treatment of wastewater. Disinfection I mentioned, by chlorine we do, but ozone is a very good disinfectant. During last Kumbh Mela at Sangam, Allahabad, government of Uttar Pradesh Jal Nigam engaged a company who used ozone for treatment of the wastewater. And it was found that it is oxidizing also the organic matter. This is working as an advanced oxidation methodology as well as disinfecting wastewater. The company is Ozone Research and Application India Private Limited. Ms. Sheta is representing the company. I request Sheta to present their technology. Hopefully, this will be interesting to you. Thank you. IPHE. Umumalay lagi siya. Umumalay. Pag siya lagi siya. Umumalay company siya.
Hello everyone, good morning. This is Shweta Jadhav. I am representing ORAPL, Ozone Research and Application India Private Limited, Nagpur. So we are a manufacturer of ozone generating systems based on PSA technology. So I will just give a short information about our company. We have started in 1996 and from that we are manufacturing these ozone kind of technologies which having a much more application in water, wastewater, drain, lake and river treatment. Right now we have 300 plus installations in pan India and actually we are now discovering globally also. So today actually I am representing application of advanced technologies in water, wastewater and drain treatment. So our manufacturing equipments firstly is the ozone generator, then nano bubbles and then variable void media filtration. So firstly, what is ozone? So ozone is unstable and decomposes to oxygen. The second most powerful oxidant, fluorine, is at the one number, half-life of less than 20 minutes in pure water. Then we will see how ozone is produced naturally and then with the help of equipments. So naturally with the help of lightning storms, then UV rays from the sun, and then by equipments is electrical motors, copy machines and then ozone generators. So in the first slide we have saw that the how ozone is produced. So oxygen plus corona discharge produces the ozone on site. One electron splits one oxygen molecule into two oxygen ion. One oxygen ion combines with one oxygen molecule to form one ozone molecule. Ozone, here is the note that ozone is very unstable. So ozone with water and wastewater. Firstly, ozone works as a strong disinfectant for algae, mold, plankton, bacteria, virus. Then strongest commercial oxidation for water treatment plants. Firstly, it gives microflocculation effect, then taste, odor and color removal, oxidizes iron and manganese, and then removes solvent and pesticides. The main key advantages of ozone, it does not add any chemicals like any other disinfectant, residual short-lived, convert to oxygen and it generated on site. For other disinfectant, we have to store that on site and we have to depend on other manufacturers. So here is the ozone mechanism of disinfectant. Ozone reacts fastly at very low concentrations with compared to chlorine which reacts very slow with high concentrations. Ozone has a strong affinity for carbon. Upon contact with the carbon containing proteins, direct oxidation occurs immediately. In contrast, chlorine must first penetrate the cell wall before oxidizing the cytoplasm. As a result, ozone contact time values are lower than those of chlorine. Chlorine, actually in conventional treatment, we have to design filter feed tank, chlorine contact tank for 30 to 45 minutes. In compared to ozone, we have to just construct that ozone contact tank only for 15 minutes of retention. So this time period between the ozone and chlorine has the major difference. So here is the comparison of ozone with other disinfection agents with comparison to contact time values and the result at the outlet of that treatment. So we have tested Giardia and virus with free chlorine, chloramine, chlorine dioxide, and then ozone. So here we can see the result. If we go with the free chlorine, the Giardia value was 122 and virus was 8. Chloramine Giardia value was 2200, virus was 1988. With the help of chlorine dioxide, Giardia value was 26 and virus 33. And if we see the ozone results, the Giardia value is very less as compared to other three disinfectant, which is 1.9, and virus value is 1.2. So here is the major difference, major comparison. If we go with the pre and post chlorination and then pre-ozonization and post chlorination. So the graph itself says the result. First graph shows the pre and post chlorination where we can see the disinfectant byproducts like THM and HAA. The graph really raised. That means the result of that outlet of that treatment will really goes high. But when we use ozone as a pre-treatment and post-chlorination, then we can see the value of the disinfectant byproducts are very less. That means when you use ozone as a pre-treatment and chlorine as a post-treatment, then the health impact of chlorine are really minor on the health of human beings. So here are some letters from CPCB on the minimizing release of 5 days. So the column says the result after using HPO technology, TSS 20, COD 50, VOD 10. So we have used this technology on the existing plant at the Nashik Tapovan, and we get that result for reducing from 30 ppm, which was existing result of that Tapovan STP, to below 10 ppm. This HPO technology was chosen due to its superior performance in lowering BOD, decreasing fecal coliform counts and enhancing DO levels and improving DO levels in the Godavari river. Further, an additional 40% of raw wastewater exceeding 1 mld was being bypassed, and TMC officials were considering installing an additional STP to treat the raw water. ORAPL actually revealed that implementation of our HPO technology could handle 40 to 60% more hydraulic load in the existing STP with minimal civil and equipment modification to existing current plant. And after that, we have installed our system to 1 mld, and now the STP is running at 1.5 mld. So here are some letters from Trimbak Nagar Parishad, Trambakeshwar, Nashik, and to ORAPL for the installing HPO technology at their premises. So this is letter from MPCB Maharashtra, 0.8 800 depth, 0 to 50% compression. This media is certified. Then antibacterial and averse to biological formation. So mainly the key advantages or silent feature of this media is the high filtration rate. It is 75 meter cube per meter square as compared to filters, which is having 8 to 10 meter cube per meter square area. Backwash water 2 to 5% depending on the inlet TSS load. Media compression up to 50%. High removal efficiency of small particle, that is 1 to 4 microns. So this is the comparison table with compared to the other filtration in the market available, that is a pressure sand filter, dual media filter, carbon filter, and disc pipe filter. So firstly, the particulate removal, all these filters say the same, it is high. Their maintenance, variable void filtration maintenance is very low, as a backwash reject water is very less as compared to other these technologies. Footprint required for given flow size, that means the area required for this filtration is very less as compared to other. That sand filter is very high, then dual media filter is medium, and disc type filtration is low. Area required for 50, actually here we have given the example of 50 meter cube per hour filter, and area requirement of VVMF is 1.13 meter square. where is pressure sand filter is 12 meters square. This type filter is 4.37 meters square. So area requirement for VVMF is very less. I will just keeping the commercial cost here. So here are some pictures of VVMF. This is actual picture. This is a complete steel mounted system which comes with the filter, then filter feed pump, air blower and control panel. So here are some result oriented pictures where we have tested the filter at MIDC Hingna, Maharashtra on WTP 13.5 MLD. We have treated that WTP with VVMF. Then we can see the first button says the outlet of WTP and then the second order says the result of after using VVMF. So here our another innovation is nanobubble generator. Nanobubbles are produced by forcing air through a specialized device that produces nanobubbles. Due to their tiny size, these bubbles provide a high surface area to volume ratio, which facilitates effective gas transfer and interaction with contaminants in the water. Nanobubbles remain suspended for extended periods, allowing them to interact with pollutants and promote pond purification and drain treatment. We can use these nanobubbles in SDP plant also for the aeration treatment. So here are some advantages of nanobubble generator: high oxygen transfer efficiency, energy saving when we use in the aeration tank for the aeration purpose, improved water quality, long bubble retention time, odor control, reduced sludge generation, chemical reduction, enhanced biological treatment, biofilm control, compact and easy to install, supports ozone and other gases, environmental friendly, improved aquatic ecosystem when we use in river, lake and drain treatment, cost effective operation. The main key advantage of nanobubble is it will increase the DO as per our requirement. So here I am starting another segment, drain treatment. We have installed many plants in pan India for the drain treatment. So here is tweet by Honorable Prime Minister Narendra Modi, where we have installed at the Madhya Pradesh for the Simhast Kumbh Mela at the Shikra River. We have installed one more plant at Assi Ghat, Varanasi, where we have treated 30 mld of drain treatment with the help of ozone machinery. So here are some treatment highlights where we are using Ora BioWeb as RCC lined sections inside the drains, then making the sequential various segments for the tanks like anoxic, anaerobic, aerobic settling. Using this Ora BioWeb as a structural lined sections among all these tanks. Using ozonization to improve DO up to 8 to 13 ppm enhances biodegradability of that sewage. Dual advantage of disinfection plus pollutant oxidation. Then effective management of drain wastewater with continuous parameter monitoring for every section of the treatment zone. We are providing online monitoring system. So here are some picture of Ora BioWeb we are using for the drain treatment. This is the picture from the Mahakumbh Prayagraj where we have treated 70 mld of wastewater, drain water with the help of ozone treatment. This is the same picture. In the second picture where we can see the results, like first beaker shows the inlet water before the drain and second beaker shows the outlet after the using ozonization treatment. So here are some results. Inlet was 300 of COD, outlet parameter as per tender was 100, but we have achieved 60 and less was 40. So we have achieved 40 COD, BOD was 16, DO we have increased more than 5 DO, total suspended solid was achieved 28. So here are some laboratory testing from third party of the Prayagraj Kumbh Mela drain water. These are pictures from Varanasi, Assi Ghat, where we have treated 30 mld of drain water. So this picture is from Assi Ghat, Varanasi, We can see the difference of inlet and outlet water. These are Varanasi Assi Ghat site photos of ozonization plant. Thank you, that's all.
Thank you very much, Sheta, for your presentation. Now, this paper is open for discussion. If you have any question or if you need any clarification, kindly raise.
Wow. Suppose in a given capacity of completely water plant, instead of conventional gaseous chlorine or say sodium hydrochloride or something like that, if we use ozone, how much commercial what is the commercial component of conventional fluoridation versus use of ozone certificate?
Actually, sir, there is a no, we can't compare ozone with chlorine because chlorine has very cheaper rate. Firstly, we can't store, we have to store chlorine on site, okay, for the treatment. Actually, yes, there is actually major commercial impact of between chlorine and ozonization tank. Yes, ozone cost higher. Yes, because it's include all the machineries. Because we are generating firstly oxygen on site and then transferring, then converting oxygen to ozone. But in terms of chlorine, we have to just depend on the other manufacturer and just have to store that chlorine on site.
Another question, suppose you use ozone as a disinfectant in the distribution system, I will put a clear reservoir. Then comes to the distribution system.
Treatment only. But in the post-treatment, we are proposing CL2 crystalline fluorine treatment only. But in the post-treatment, we are proposing CL2 crystalline fluorine has to maintain because there are huge kilometers of pipeline from the treatment to yes. Yeah.
Any other question? Any other question? Related to this. Now, what Mr. Bhomik raised, yes, it cannot be compared. I mean, she also admitted chlorine is cheaper and at the advantage of residual chlorine. But the issue is that ozone has got extraordinary power to reduce the BOD also little bit. That is, some oxidation effects are there. That is advanced oxidation. So this is the advantage that ozone might have. It is not that it is not having. In public water supply, we are not ozonizing, but the bottle manufacturers are ozonizing. But the application of ozone in the drain treatment or grey water treatment, that has been tried in Kumbh Mela, that was successful, no doubt. I, on behalf of Jadavpur University, also working with, it's not that we are not also working with the ozone, we are thinking whether this can be applied because issue is that for the wastewater, that residual effect need not be there. In public water supply, drinking water supply, residual chlorine is an important in the distribution system. In the sewage treatment system, ozonization is not that way restricted because residual ozone is not required. Again, cost is a very important thing. Normally, Namami Gange, they recommend chlorination. And chlorine has got advantage, but chlorine is depending upon the pH. Because hypochlorous acid, hypochlorite ion, these are the two factors that is important because when adding chlorine in water, if pH is less, 5 or 6, hypochlorous acid is the main in 7.5. So 50% HCl, 50% OCl is there. So that if the BOD is more, say I have 25 or 30 in water, so fluoro organofluoro compounds could be formed. That is again with respect to ozone, these chances are less. That is advantage.
Sir, I have shared that graph again where we can see carcinogenic element. So the health impact when we use pre and post chlorine, that it's impacting the human beings. But when we use pre-ozone and then post chlorine, it have very less impact on the human being. So we can't compare health aspect with the first.
If we conform to Honorable National Green Tribunal standard, then formation of trihalomethanes minimum. But if your BOD is 25, if you are conforming to ammonia standard and BOD is 25, 26 after treatment, there could be a chance. Thank you very much. So we now break. Any more question now? We now break for 15 minutes for tea, and then we assemble to hear more on wastewater management. So we break for 15 minutes.